Yes, class. Today, let us look at the mode as the last measure of a central tendency. The mode, it is actually the value or the figure that is the most repeated in a distribution. If, for example, students sat for an examination and their score, these are the marks, and their score is maybe you are given that as the score, and maybe in this class we had 1, 2, 3, 4, 5, 6, 7, 8. We had 8 students who sat for that particular examination, and now you are asked, what is the mode score or the mode marks? So you just come to your data and then you try to find out which is the value that is most repeated. If you take 33, it is only appearing once. 44 is also appearing once. 36, we have 36, 36, and 36. So 36 is appearing actually 3 times. 40 is once, 45 is once, and 53 is once. So here, the mode will be equal to 36. The value that is most repeated becomes your mode. A set of data can have the following kind of modes. Mode can either, or a data can either have or be unimodal. A data can be unimodal. Unimodal simply means that it has one value. It has one value that is most repeated. If the data has one value that is most repeated, that data we normally say it is unimodal. And a good example is what we have here, where only 36 was the most repeated. Data can also be bimodal. It can be bimodal. Bimodal here simply means that we have got two values that are most repeated. Like for example, in this data, think of a case whereby maybe we had 44, 65, and maybe 44. You will find here now, we have got 36 that is appearing 3 times. We are going to have 44 that is also appearing 3 times. And therefore, the mode for this distribution would be 36 and 44. Where we have got two values as mode, that data is normally referred as the bimodal. Lastly, data can be multimodal. Data can be multimodal. Multimodal here, it is a case whereby the data has got more than 2 values that is going to be our mode. If we have got 4 values that are actually appearing the same number of times and they are the most repeated, then we can say that data is bimodal. Let us now go to mode from ungrouped data. Mode from ungrouped data. It is the simplest, and actually that is what we have been doing here. The ungrouped data is this kind of a data whereby the values are just separated by the commas. So it is a matter of locating the value that is actually appearing the most number of times in that particular set, and then you are able to see the mode. And remember, you are going to have either a unimodal if it is only one mode, bimodal, or multimodal from this ungrouped data. Then we can talk about mode from grouped data. Mode from grouped data. Mode from grouped data. Remember, grouped data is the data that is organized into classes. If we have this, let us talk about maybe it is profit this time. Maybe the profit that is being made by firms or businesses. Which is our F. So the profit, we can say it is in 1,000. 15, 20 to 25,000, 25 to 30,000, like that. So the profit that was generated by these firms, you can be given, maybe the firms that realized a profit of 10 to 15,000, they were maybe 8. From 15,000 to 20,000 profit, they were 12. 20,000 to 25, they were 6. and 25,000 to 30,000, maybe they were 4 farms that registered such kind of a profit. And then now you are told, find or compute the model profit. We compute the model profit. When it comes to this kind of a question, first of all, we need to locate what we call the model class. We need to locate the model class. The model class, it is the class that is going to have the highest frequency. The class with the highest frequency in this case, it is actually this class, 15 to 20,000, because it has got 12 as the frequency, where others are having less than that. So the model class is 15 to 20, the class with the highest frequency. The formula for the mod is given by L plus F1 minus, FO minus F1, then over twice FO minus F1 minus F2, and then this part we multiply by the R. FO, it is the highest frequency. The highest frequency is FO. F1, it is the frequency above FO. F2 is the frequency below FO. And I is the class interval, or the classes interval. So we need to get them. The good thing with mod, you don't have to create an additional column. The way the table is, we can be able to compute the mod. In this case, we have our FO, it is 12, the highest frequency. F1, it is the frequency above the frequency of the highest, which is actually 8. F2, it is the frequency below the highest frequency, which in this case is 6. And the class interval is just a matter of subtracting the upper limit minus the lower limit, which is going to be 5. So our mod in this case will be given by what? L, which is actually the lower class limit. L is the lower class limit of model class. So in this case, our L will be 15, the lower class limit of the model class. So it's going to be 15 plus, into bracket, FO minus F1, which is 12 minus 8, over twice FO minus F1 minus F2, and then we shall multiply by 5. Therefore, mod will be 15 plus 4 over 24 minus 14 minus 8 minus 6, and then we multiply by 5, which will be equal to 15 plus 4 over 10 times 5, which will be equal to 15. This one will go twice here, then this one is 2, this is 15 plus 2, which is actually 17, and that becomes the mod, and that becomes the mod for that particular distribution. So with the mod, it is quite simple, but I want also to send maybe a clarification. Anytime your data or your classes are not continuous, for the mod and the median, you need to make them continuous. You can be given a case whereby you are given the classes from 0 to 5, the other one starts from 6 to 10, the other one is 11 to 15, like that. You can be able to realize that where this class is ending, it is not where this one, the next one is beginning from. Where this one is ending, it is not where the next one is beginning. So we need to do this. You add 0.5 to upper limits, you less 0.5 to lower limits, like that. So what you will do here, apart from the first value here, we are going to have 0 to the upper limit, we add 0.5, so it's going to be 5.5. Then here, this is the lower limit, we less 0.5, it's going to be 5.5 to this one, we add 0.5, it's going to be 10.5. We less 0.5 is 10.5. We add 0.5 is going to be 15.5. And by so doing, your classes becomes continuous such that where this one is ending, this is where the second one is beginning from. And now, if we were to get now the mod, we now use the lower limit as actually going to be what? 15.5, because the other one will be 15.5 to 20.5. So we are going to use this value. So you must be very keen. If your classes are not continuous, you will have a responsibility of making them continuous first before you go ahead and calculate the mod. I want to stop there and thank you.